This video is one video from a series about comparing edge boards for computer vision. In a series of this video, I compare boards not only in terms of performance, but also from the side of convenience and simplicity for development. One video, one platform. All videos are available on my channel, and at the link in the description you can find a final table with different boards and the article about how I choose the logic of comparing. Today we will talk about Khadas Vim 3 based on MLogic A311D chip. There are several other boards based on this chip. For some of them this video will be applicable, but I'm not dig pretty deep in this. I have long waited to work a bit with this board. I consulted one project where it's used, but never tested myself with my hands. All the thing in this video will be either from my test, either from some consulting experience. And the story in this video will consist from three parts. In the first part, I will evaluate Khadas on a number of criteria that I think are important for computer vision boards. And in second part, I tell a couple of words about main development protocol for this board, and in third part I will summarize everything and tell my opinion about this board. Okay, let's start. How easy to flash? Everything fits surprisingly well. First of all, you need to flash the firmware through a special tool. Here it is, and after that you just load your board in the upgrade mode with your SD card, and everything work. My mark is 5 stars. How easy to work with this board? There was no problem for me on casual level. Regular SSR works well, no disconnect, everything works stable, regular Python and regular packets, but I don't like the documentation. Often you need to collect different fragments from this documentation to understand the whole picture. There are no logical guide and logical transition from one point to another. Let me show you. Here you can find how to install the neural network inference framework. Here you can find how to install the SDK for model conversion. And here you can find how convert models for inference in Python. And everything is a bit messy, and it's pretty hard to find a complete solution how to take your model, convert it, start on the device. There is no one clear guide. Of course, you can Google a bit and find everything. I just spent 2 or 3 hours on this, but I prefer when everything on one page and not in different location. But of course, you can find everything and everything will work somehow. Um, Here is a second way how to prepare and infer neural networks through the tangent framework. But there are problems here too. Nothing works out of the box at the moment. When working with a new board, there is an issue that completely blocks the pipeline, and before you stumble upon this issue, you can Google for a couple of hours, but it's pretty easy to fix and everything starts working. So I think this is 3 stars or probably a bit more. How conventional is the system? Khadas use the Ubuntu 20 build, which have the driver installed, and it's a good option, so everybody works well and there is no any problem. Also Khadas have Android firmware, but I didn't try it. 4.5 stars. Community support. And community support is poor. Just look at these Gits and how many stars they have. It's pretty low amount of stars, and community didn't use it pretty often. And Khadas have internal forum for question. But the only support is responses from Khadas team. But you can find their responses and they responding pretty fast. So it's a good, but no big community around Khadas. I would say it's 3 star or probably less. Official model zoo. Official models are only in the official examples for this board, and there are only a few of them. Not all of them can be opened in the original frameworks, and there are no training script for them, and the problem is the same for KSNN and for Tangent. So only 2.5 stars. Unofficial model zoo. In fact, there are no unofficial models from the community. Of course, you can say that Tangent models are from community, but it's not feel like this. So only 1.5 stars for unofficial models. Easy to convert. How easy to convert random models, and it's a strong point of Vim 3. The converter for Tangent is very stable. Just don't forget to quantize the models separately. It supports quite a lot of formats. The converter from Khadas works with certain framework version. For example, only with PyTorch 1.2. But ONNX and TF-Lite support are good. A lot of models are converted without problems. I check myself a bunch of models from different frameworks. But many of models are not supported. For example, I export YOLO v5, the same YOLO v5, into ONNX and into TF-Lite. And ONNX version convert good, and TF-Lite version didn't convert. And of course, you may forget about transformers model or about some recurrent neural networks. So the whole picture is a bit blurry. Some models working, some models non-working, some frameworks supported, some not fully supported. In my opinion, if author will focus on one or two format like ONNX or TF-Lite, it will bring sharpness to this project, and the process will become much clearer and understandable. So at this point I will give only 4 stars, but in my opinion the Khadas Vim 3 have a lot of potential to development. Easy to debug problems with conversion. With Khadas framework you will have a lot of debug info, so it's pretty easy to track your problems and work with them. But I assume that sometimes it's probably a bit more debug info than that will be helpful for you. So 4.5 stars I think will be enough. And let's speak about the board itself. And as usual we will start from processor. And processor is pretty good for this board. Actually there are 2 different processors. One is 2-core processor for slow computation, and the other one pretty fast processor with 4 cores for fast computation. Of course the first one is pretty low energy, and the second one will drain your energy. They're pretty fast and especially together, so I will give 4 stars for the processor. From mechanical point of view, I think that everything is pretty good. You can see that I decide not to connect fan to this board, and the temperature is pretty stable even when I run neural networks. But of course it's a bit more than comfort temperature, so in the real product I think that you will need fans or bigger heat removal system. I think it's 4 stars. From construction point of view, you can see that the board have mounting points, but you need to understand that Khadas Vim 3 is a dev board, and the dev board is not focused on NPU computation. There are no other form factor other than the original, only the original M-Logic processor. In fact, you take this board, or you need to develop your board from the scratch with original processor. It's okay, and the board is quite good, so I think it's 4 stars. The board is very easy to buy. Of course, like you can see, there are a lot of pins like Raspberry Pi, and there is a Python library for communication with them, and some C++ library as well. The speed of this board is surprised me. I think that this is one of the fastest board in this price range. Just look, Yola V5S 640 on 640 pixels took only 100 milliseconds to run, and YOLO V5 224 on 224 pixels is 30 milliseconds. I think the speed is good, and on some project you can work even with 2 or 3 cameras, depending on your project, of course. But there is one interesting point about Khadas. For fast models, Khadas is not that fast. Even for YOLO, it's visible. The difference between 640 and 224 is only 3 times. For different boards, the difference usually 4 to 6 times. It's because small models are not optimal for Khadas. And the good example is MobileNet V1 and V2. Check here the comparison with Coral. The board is much slower than the Coral, but on big YOLO V5 the board is 2 times faster than Coral. So you need to understand this and use this knowledge in real project. In the description you can check a lot of different models and how fast they are. The second part of my story is a brief overview of the development process and how the protocol will look like. And there are few different approaches for Khadas. Both approaches start by writing to the system SD card and flashing Khadas to it. I already showed this page. The first approach is to use the pipeline from Khadas itself. You need to install AML conversion system on Ubuntu host machine. I tried to use it on Windows host machine and have some problems, even on both different Windows machines. After you install this, you need to install KSNN API to your Khadas board. After that, you need to export the model and write some logic around your model, and in Khadas, in KSNN, you can find a lot of different examples, and some of them are pretty good. For example, here you can see Flask server and YOLO v3 inference. Pretty simple example how to use such in neural networks and how to provide such inference. And run your sample on the board. The second approach is through using Tangent, and you should start, as I already mentioned, from fixing the error that is actual for current version. After that, you need to compile Tangent on Khadas board. You should use this compilation instruction that will compile your Tangent with support of TeamVX library from VeriSilicon that allow you to use your NPO chip. After compiling Tangent, you should export your model through Tangent converter, and Tangent, for example, have online converter that works pretty good, but you can install it on your PC or even build it yourself. After that, you need to make quantization to your model, and the only available quantization is asymmetric quantization, and it's supported by TeamVX NPU. After you compile and quantize your model, you also can take some example from Tangent to how to use it and write logic around this. But do not forget pretty important part, that you should use context to start your model on your NPU. And there is only one sufficient example in Python, but of course there are a lot of examples on C++. But in Python there is only one example how to append context to your board. And after that you need to run. Let's move to the third part and summarize everything. I like Khadas board. This is a fast board with a wide range of conversion options. But many of these features are not stable. This determines the use for this board. If you want to use Khadas for a hobby project or to study neural networks, this may not be best board for this. You will have to spend a week or more to set up all your pipelines and create a working environment. But if you are using Vim 3 for product development, things are changing. 1 or 2 additional weeks is not much for a product, but you will working with faster platform that will support a lot of different neural network architecture, and that will support different pipelines. I have seen several working products based on the Amlogic chip, which means that everything works well for this board. But I didn't see any hobby project on this board, so I think it's the main point that I should mention. If you find this video helpful, subscribe. There will be a lot of same videos on this channel. Thank you for watching. Bye.